Hello, guys. Again, good afternoon, good evening to some of you. My throat is a bit itchy today, so I hope you guys bear with me. So yeah, as usual, we'll be having a recording of this webinar uploaded on YouTube. So maybe by tomorrow we can send you guys the link. So today and the next series of webinars, we'll be focusing on switches. So we're going back to basics. We're gonna understand what the different functions of the switch are, and then the topics and the actual content would sound a bit more technical than usual because we're going to be using terminologies based on the standard IEEE information. So I hope you guys bear with me as well in terms of that. So topic for today is regarding network switches in general. So I'll be talking about an introduction, what the switch is for, some information on the OSI model, layers 1 to 3, because the switch concentrates on layers 2 and 3. And then what are the different types of switch, different types of configuration options in terms of um, the form factor, in terms of the different layers of switches and so on. And then we'll have the Q&A portion afterwards. So if you guys have any questions, you can type it on chat. Nancy is Michael and Michael are here today as well. So they'll be answering some of the questions in case you guys have. Okay, so what is a network switch? A network switch is actually a very important part of the network. Some people take it for granted. They might think that a switch is just an accessory for example, an access point. Maybe you just use a switch to provide data to an access point or to provide power to your IP devices. But a switch is actually one of your core items. You need to have this to have communication between your hosts or between the clients on the network. It acts like a bridge to pass on information or to pass on data from one point to another. Now, the switch typically operates in the layer 2 of the OSI model. But of course, there are also layer 2 plus switches and layer 3 switches. So that I'll be talking about in a while. So what makes a switch special is that it has a MAC address table. So it learns devices over time to know where to send those individual frames on the network. So you can find a switch in almost every network setup, at home, in the office, and different organizations, especially large organizations. Some of you might be wondering, okay, I'm at home right now. I can see my setup, but I don't see any switch at all. So actually, you do have a switch. If you look at your ISP, your internet service provider's router, the router has different components packed into it, especially for Soho routers. Now, the main component is the router function. It can do NAT. Maybe some of it has a modem function as well to do PPPoE. So the router also has additional services such as a DHCP server, DNS server, firewalls, etc. Now, the physical ports on that router is actually a network switch. Most of the time, it's an unmanaged network switch. So in some cases, there are special routers that can also have a bit of management in terms of the switching capability. And then modern routers right now already have wireless access points built in. So that's your Wi-Fi built in on the router. It's actually an access point as well. So all of these functions, all of these features are combined onto your home router. But usually for network deployments, each of these components are separate because we have having this option separate, not being a part of that same router, you can have more customizations and you can have full configuration of your network service. For example, in a typical network topology, here you have your router, which only acts as, let's say, for example, NAT to translate the traffic. And then you have the firewall, which has more services if it's a specified system. And then most of the network, they have their own DHCP server so that they can handle more clients. They can handle more subnets in case they have multiple networks across the same location. And then they also have their own DNS server, which is also separate. Basically, here they can control what URLs they can visit. If they have local URLs that they customize, let's say their own server, they can also configure that on the DNS server. And then some networks also have their own radius server. So basically, this is a database for all the clients um, connecting to their network. They have their individual usernames and passwords. And then you have your network switches, you have your core switches, you have your access switches, and then you have your access points as well. But again, on typical routers, these are all combined into one single box. But of course, they have limited options as compared to individual items that are deployed. Now, going back to the topic, so let's talk about the OSI model. I'm only going to be talking about layers 1 to 3 today because that's where most of the switch data comes from. But there are actually 7 layers on the OSI model. First of it is the physical layer. You have your data link and then your network, transport layer, session, presentation, and the application layer. So the first layer is the physical layer. By the way, the OSI model, it's like the backbone it's like your standard process of communication for all your network equipment. So the physical layer composes of all your physical media, the way that you access your network physically. For example, your copper connection, your fiber connection, the wireless connection that is actually part of the physical layer as well. Bluetooth connection, Wi-Fi connection, that's all part of the physical layer. Now, hubs and repeaters are also part of the physical layer. Now, moving on to layer 2, data link layer, this is where you start to transfer the data on your network. So the way that it transfers data is through frames. So here, this is where your switches belong to. So you have your switches, you have your bridges, you have your Ethernet. And then on the layer 3 network, this is where your routers belong to. On the network level, communication is through IP address. So the method of transfer is through different packets on the network. Now, one thing very important to take note of is that the lower layer will always encapsulate the upper layer. For example, here on my layer 3 network, let's say I'm transferring packets between my clients. For me to transfer that packet to a switch, to go through a switch, for the switch to understand what it is, the Ethernet needs to encapsulate that or could put that inside a frame. So this frame is then transferred over from your switch to different parts of your network for it to be read or understood by your switch. Wait, let me try to explain that in graphical form. For example, on the L3, on the layer 3 level, you have your packet. You want to transfer, let's say, a file from one client to another. So as that packet exits your computer, it passes through your NIC card, your Ethernet adapter. The Ethernet would add a Ethernet header. So when that happens, it contains that packet inside a frame. So once your Ethernet contains this packet inside a frame, it could then head on to pass that information on layer 2, meaning on the switch side. Now, same thing happens if we reverse the process. Let's say, for example, from the switch, I want to send this frame onto the layer 3 network. So once it reaches your Ethernet, the Ethernet will strip off the frame from will strip up the frame from that data and then take the packet out and proceed to let the packet through the network. So like I mentioned, on the layer 1 level on the physical layer, that's where hubs belong to. Now, hubs can look like switches as well. You can see them it looks like a standard switch with multiple ports, but the function is very, very different. And the way that it broadcasts data is also totally different. Now, this is how data is broadcasted if you use a hub on your network. So as a client sends out data, let's say this is the client A, it sends out data to the server. Let's say he only wants to give information to the server and nothing else. What a hub will do is just repeat that data and broadcast it on all the ports. So that means all the clients will receive that same type of information. You have a lot of headroom that's being wasted, a lot of processing on the network side is being wasted because it keeps on repeating everything. So a hub is not smart enough to know which port I should send this frame to or this data to. So that's one downside of having a hub. If I'm not mistaken, hubs are already phased out. 2011, 802.3, the amendment on that on IEEE, they have advised or advise everyone not to use hubs anymore and to use switches instead because it's more optimized on the network. Now, if we look at the switch, which works on the layer 2 level, this is how it transfers the data. So from the client side, as it sends out packet, the switch it sends out a packet. The switch will accept that in a frame, and then it would know which port you want to send this frame to, and then it will proceed to send that on the specific port. So as you can see, it's not sending it to other clients in the network. Your network would be optimized because of this. You wouldn't waste any processing or bandwidth in terms of the transfer of data. Now, I mentioned that the layer 2 switch has a MAC address table. So what is it used for? So a MAC address table contains all the MAC addresses, all the lists that the switch learns over time, as well as which port that MAC address belong to. For example, my first MAC address here, my switch detected that it's coming from port number 1. And then the second MAC address on the list comes from port number 3. Third one here is on port 22. Fourth one here is on port 24. Now, all switches have a MAC address table, regardless of its type. Unmanaged switch, layer 2 switch, layer 2 plus, L3 switch, they all have MAC address tables to know where to transfer those packets. Unmanaged switch is actually capable of doing this as well. The only thing about unmanaged switches is that you're not able to configure them because they don't have a user interface. Now, on the layer 3 side, it's a bit different in terms of how they take note of which where I send data to. So the layer 3 side, switches, hosts, and routers, they keep this ARP table or address resolution protocol table. So here on this list, they have the IP addresses, which are the means of communication on the layer 3 network, tied to specific MAC addresses. Now let me go back. So on the MAC address table, you have your MAC address, and then it ties it to a specific port. This is how the switch knows where to send this particular frame to, on which port, which MAC address. On the ARP table, you have your IP address, which is tied to a specific MAC. So whenever a client wants to communicate with a specific IP, it would check it on its table. Which MAC address is this IP address tied to? And then from there, it would send that information to the switch, so the switch would know where to send the data to. So let's try to check, or let me try to detail that step by step. So for example, host A right here, he has its own ARP. So let's say his ARP table is still empty. He doesn't know what MAC address host B is, but he wants to communicate with host B. So host A here knows the IP address of host B, but he doesn't know the MAC address yet. So the first thing it's going to do is it's going to send a broadcast packet out. So once it sends that broadcast packet, as it passes through the Ethernet adapter of that client device, the Ethernet will encapsulate that packet into a frame. So that frame would then head on your switch. As your switch receives that frame from this client device, it would then list that on your MAC address table. So now it knows that host A with this MAC address comes from port number 2. So that's how the switch builds up its MAC address table over time. Now, since the switch doesn't know yet where host B is on which port, it's gonna broadcast a multicast packet on the network. So it's gonna broadcast that to all the active ports, but it's gonna do that efficiently. So once he send out a broadcast to check where this MAC address is on the network, and host B receives that information. Host B will then respond to the switch, hey, I'm here at port number 8. So the switch would then proceed to give that information back to host A, and then A would now know and will fill in his own table to list out, okay, host B 192.168.1.2 belongs to has this specific MAC address. And then from there, your host A can directly communicate to host B already. So for the sake of this demo, let me show the other clients as well. Let's say they also want to broadcast packets. So as they broadcast out, the switch will detect the source of that broadcast, and then it will list it out on his MAC address table as well. Let me go over that one more time. So for a client to transfer data to the network, wherein, for example, he still doesn't know where the location of the client is, what the MAC address is, he only knows the IP address. First thing he's going to do is send out a broadcast packet on the network. As the packet comes out that client device, the Ethernet will encapsulate that into a frame so that the switch can understand what it is. Now, when the switch receives it, it's going to list it out on its own MAC address table, and then it starts to broadcast a multicast packet on the network in case that specific MAC address is not on the list yet. Now, after it sends a broadcast, it's basically asking, hey, who owns this MAC address? So when host B sees that information, he will reply and say, I own this MAC address and this is my IP address. So once it responds, the switch would recognize that that message is for host A, build that up on his MAC address table. Host A will keep that on his ARP table, and then from there, communication would proceed as usual. So over time, your MAC address table would be filled. Each of your ARP tables on the individual host will be filled as well as you transfer and broadcast packets on the network. So what are the different switch configuration options? So in terms of the form factor, the most common switch may be our desktop switches. So these are basically switches that have limited number of ports. Maybe you have 8 port switches, maybe you have 5 port switches. But usually you use this for basic setup. Maybe you just need more LAN ports on your environment, or let's say for the office area, you just need to have more ports. Now you have rack mount switches. Basically, these are 8 port to 48 port switches. They come in different sizes. Let's say, for example, 13 inches, 19 inches, but they're all rack mountable. And they fit on a standard rack mount slot. It can come in like 1U or 2U, meaning how many slots it can occupy on the rack mount. And then you have industrial switches, which are basically ruggedized switches that can withstand harsh weather. Now, the form factor doesn't affect what type of switch it is, if it's unmanaged layer 1, layer 2, or layer 3. But basically, it just changes how it's installed physically. For configuration options, you have first the unmanaged switch. So again, an unmanaged switch is basically a switch without a user interface. It functions as a normal switch, like my diagram just now. So layer 2, it can process that properly, but it doesn't have any features in terms of VLAN. It has a MAC address table, but you won't be able to view that information. You won't be able to do STP, port mirroring, diagnostics, and all that. So it's basically a means to transfer data from one point to another. And then there are smart switches on the market right now. By the way, smart switches usually are not fully layer 2. It's like a basic layer 2 switch with some options enabled, but not all the layer 2 features of a managed switch. But some other brands market it differently. So they call their layer 2 switches smart switches as well. But this is the term used in general. And then you have a managed switch. So a managed switch is a fully managed layer 2 switch with all the layer 2 functions such as VLAN, your viewable MAC address table. You have link aggregation, spanning tree, which takes care of the loops. You have your access control list, so you can do whitelist or block list. You have SNMP if you want to do remote management or remote monitoring. And then you have, of course, your logs, so you get information on what types of data or what type of error you have on the switch. You have port mirroring, you have diagnostics, you have a lot of functions on layer 2. Now, another configuration option is the PoE function. Some switches have PoE capability, some don't. Basically, power over Ethernet means you'd be able to power up standard devices in terms of IP. For example, you want to power up devices that need 15.4 watts of power or PoE plus as well. In the succeeding webinars, I'll be discussing about PoE plus plus as well. Now, layer 2 switches, layer 2 plus switches, how it differs from the rest of the switches is that basically they have the full layer 2 functionality, VLANs and all that, but it has some L3 features built in. Now, this differs from brand to brand, but for EnGenius L2 plus switches, basically that's our ECS switch. All the cloud switches are categorized as a layer 2 plus switch. So these are the advanced options that we have, which are usually found only on layer 3 switches. So one of them is DHCP snooping. The main purpose of DHCP snooping is to prevent unauthorized rogue DHCPs on the network. So that means if I have an existing DHCP server and then somebody else plugs a router on the network, so your layer 2 plus switch can prevent that router from distributing IP addresses to your internal network. So in a way, it protects it. Another feature that the layer 2 plus switch has is the DHCP relay. Some other brands call this the DHCP relay agent. So what it does is it allows a client to talk to a DHCP server on a different subnet. Because usually for a client device to talk to a DHCP server, they have to be on the same subnet, meaning they have to be on the same network. For example, my DHCP server is sitting on 192.168.1.1/24. So my subnet size is 255.255.255.0. If I have a client device that's on, let's say, 10.0.0.x, it won't be able to see that DHCP server because it's a totally different network. So what a DHCP relay agent will do is it's going to try to act as a bridge for this client device to see that DHCP server and relay all the information back and forth. So essentially, it's like bridging two networks together. And then we also have ARP inspection. So ARP inspection, basically it prevents invalid ARP packets from coming in. It works hand in hand with DHCP snooping as well. So it protects your network from attacks and hacks. Our layer 2 plus switches also have static routing. This means you can try to optimize your routing table properly. So instead of using a dynamic routing, which is done on the background, you can specify which path your devices will take. Now, the layer 3 switch, its benefit over the rest of the list switches is basically the router functionality. So what it can do is it can have a DHCP server. It can act as a router. It can provide IP addresses to the clients. Each of the ports can have its own DHCP server. You can have different VLANs as well through layer 3. The main thing about layer 3 is it has its own ARP table. So it knows the IP addresses, which belongs to what specific MAC address. So it's able to do that because it's sitting on layer 3. Now, can it replace your router since it has a routing function? In some cases, yes. But there's a couple of features that layer 3 switch doesn't have that dedicated routers have. Those are NAT, network address translation, and the WAN port. An L3 switch doesn't have a WAN port, so it's not able to be a fully functioning router unless you don't need those two options. Another thing why some people don't use layer 3 switches to replace the routers is because of the cost. Layer 3 switches tend to be very expensive as compared to using a dedicated router. So there's another feature on some of the other switches, which is used for management mainly to make it easier to use. These are called stacking switches or stackable switches. So what it is basically you link multiple switches together, not through Ethernet, not through fiber, but you use a proprietary stacking cable. Usually it's plugged on the back, or some other branch you plug it in front. So you link the switch physically together so that you can manage them on one interface. So in a stack, all of those switches would carry a single IP address. So when you access it in management, it will be only through that window. And then from there, you'd be able to see all the ports. You can configure VLAN and all that. One downside of using stacking switches or stackable switches is that you have an increase in processing, because apart from the normal data that it processes, let's say all your frames that are going in and out of the network, you have additional overhead for the stacking information that runs between your switches. We don't have stackable switches right now for EnGenius, but one good workaround is the cloud management. Because again, usually people would use stackable switches in order for them to make it easier to manage switches in bulk, let's say group switches. But for the cloud, once you have your switches inside the network, basically they carry the same setting. So it's like group configuration for your switch. Of course, unless you override one of those switches. And then from the cloud as well, you can see all the ports, how the switches are interconnected through the topology view or from the switch interface as well. So if you're in the market for stackable switches and you just need the stacking function just for management, you might want to look on the cloud controller as well. So any questions, guys? I think we had a mouthful in terms of different terminologies on the switches. But if there's anything that's not clear to you guys, let me know so we can address it. Okay, I see questions coming in. Let me check. Okay, one question here is stackable switches, can it combine with other brand switch? Short answer is no. Because stacking switches for most brands, they use proprietary connections. So each brand have its own type of cable to connect a stacking switch together. So it's not going to be, you won't be able to combine different brands in terms of stackable switches. Will the slides be made available? Yeah, I can share the slides to the sales team. So the respected sales can pass it on to you guys. How many switch maximum for a stack? That depends on the brand. By the way, EnGenius doesn't have any stacking switches. Sorry, I just built this image for the sake of showing what a stacking switch is, but we don't have stacking switches. CLI commands, do we have it in PDF format? We have that. We have a list of CLI commands for our switches, and it's available in PDF. It has a lot of pages, if I'm not mistaken, 900 plus pages of CLI commands, but we can share this information to you guys as well. I think this CLI commands list is also on Partner Portal, but I have to double check. Can you explain something about the cloud controller? Yes, sure. I'll be going over the interface of the switch on the controller in a while. So after I go through your questions. L3 switch support, does it support full layer 3? If a switch is at layer 3, it definitely supports full layer 3. But for EnGenius side, we don't have layer 3 switches. I think I'm going to flash what we have on our end just a while. Okay, so what EnGenius has are layer 2 switches, fully managed switches, and layer 2 plus switches. So let me show you guys that right now just a while. So let me show the cloud switches first. So these are our cloud switches. Let me show you the standard gigabit switches first. So it comes in different formats. So all of our cloud switches has the same features software-wise. The difference would be on the form factor and the configuration option. For example, we have 8-port switches. We have basically PoE switches and non-PoE switches with different power budget depending on if you need PoE or not. So, but all this are a layer 2 plus. So all the ports on our cloud switches, on the normal cloud switches, are running gigabit, and then we have SFP slots as well that has either gigabit or 10 gig SFP. We also have multi-gigabit switches, which are available next week. Now, the difference on multi-gigabit switches, I'll be talking about this on the next set of webinars, is basically you have faster throughput on your Ethernet side, on the copper side. So instead of having the usual gigabit speed on your LAN port, multi-gigabit switches have either 2.5G in terms of the speed transfer, up to 10 gigabit Ethernet maximum. So of course, you can also fall back to 5 gigabit Ethernet, depending on your cable connection and the client connection. Let me show you guys our EWS switches as well, just a while. By the way, our cloud switches are considered hybrid switches because you have different management options for them. So you can either manage them on standalone mode, meaning through its IP address, through a browser, or you can manage it through the cloud portal. A third option that I think most of you guys are not familiar about is that you can actually also manage the existing cloud switches, ECS switches, through an Easy Master. So, for example, you have a SkyQ1 or you have an Easy Master running in VM. You can actually add our ECS switches as well. So, as usual, you'd be able to detect this or this switches on topology view. Okay, apart from the cloud switches, we actually have EWS switches as well. So one unique feature of the EWS switch is that it has a built-in controller function. So you can actually manage up to 50 APs on an EWS switch. On the cloud switch, it doesn't have the controller function at all in terms of managing APs. So for the EWS switches, we have 8-port switches, 24-port switches, and 48-port switches too. So they come in different port configuration and different power budget options as well. But we no longer have non-PoE switches for the EWS side. Okay, one question here is about VLANs. By the way, I'll be talking about VLANs in a separate topic as well. But let me answer your question. Question here is, can we set different IP address range for different VLANs when we're configuring networks larger than 255 devices? So yeah, you can definitely have each VLAN running on different subnet or different IP ranges. For example, one of your VLANs is on 10.0.0.x. You can have another VLAN in 192.x.x.x and so on and so forth. Now, VLANs are usually used so you can isolate different networks from each other, and if you want to separate them from each other. Also, you can set up different memberships on VLANs. For example, let's say you have 3 VLANs, sales, technical, and admin. You can make it so that sales would see your internal NAS so that they can transfer data and get media marketing data. You can also make it so that technical would see that same information, but you can block admin from accessing that server because they don't need it. So there are a lot of things that you can customize in VLAN, but the main thing is for separating networks. Does your layer 3 switch support multicast and unicast control? Sadly, we don't have layer 3 switches yet. What we have right now are layer 2 plus switches. But yeah, we support multicast as well on our switches. You can tweak IGMP options as well. When will be the next webinar? Sorry guys, we haven't blasted out our EDM yet. But the next webinar would be next week at the same time, 2 p.m. So for 3 succeeding weeks, it will all be on Wednesday at 2 p.m. Does your switch support 802.1x? Yeah, we support 802.1x. You can link it to an external radio server or another database. For PoE switches, does it support full PoE? Yes, it supports full PoE. So it supports PoE and PoE plus, meaning 802.3AF and 802.3AT. Soon we'll have switches that supports 802.3BT as well. Meaning you can have a maximum, if I'm not mistaken, 60 watts or 100 watts of power per port. So those are called PoE++ switches. So yeah, let me show you guys what you can do on the cloud if you're managing the switches. So first of all, you have to be on your organization first, and then your specific network in order for you to see the switch options. So once you have the configuration option enabled, you can go to your switches. So here, as you can see, For the access points, all the APs that belongs to this specific network, right now I am on EnGenius Type A org 8th floor network. All the APs that will be on this network would carry the same setting. So the same thing applies for the switch. All the switches that are on this network would carry the same setting unless I override it on individual switch pages. So my configuration option right here under switch settings would be applied to all the devices right here. So on the cloud, what's great about it is that you can see all the ports that are currently running. This refreshes every time if it's active. If it's not active, it refreshes every 5 minutes. So here you can see all the switch configuration, no matter if what type of switch model they are. For example, my switch right here, which is the ECS1528FP, I can see which ports are being utilized. I can see immediately which ones are running PoE by the legend. For example, ports 1, 2, 4, and 19, these are running PoE right now. They may be powering up an access point or another IP device. And I can see that the uplink port, how it connects back to your main network, is on port 24. So the white ports right here means that there's nothing plugged on them. And then the orange port right here means that you have a device that's plugged and it's running a lower speed, 1000. So once we release our gigabit, our multi-gigabit switches, 2.5G, 10G switches, you should be able to identify as well which ports are utilizing those speeds. And straight away in a glance, you should be able to navigate through your different VLANs as well. For example, VLAN 888 right here, it's tagged on port 24, represented by T, and port 3 is untagged right now. So you can see that on the VLAN setting. So you can see the same information on the rest of the switches, but of course, if you want to go to more details, you just have to highlight the switch right here and go to details, so you'll bring you to more options. So once you get into your switch, it will give you additional options such as CPU usage and memory usage. Here you can identify if your switch is overloaded or not in terms of processing. If it's running PoE, you can see the current power usage. You can see that per port as well. This is where you can configure the IP addresses. And further down is where you can configure VLAN. Now, a VLAN for the cloud, the way that they made the UI is very user-friendly. So you can easily create VLANs. You can easily tag or untag different options for VLANs. Now, again, I'll be talking about VLANs in depth on the next webinar. Sorry, not the next webinar. I think it's the week after's webinar. So here, if, for example, I want to tag ports using VLAN ID 1, I just have to click on that specific port. Now, it shows up as either tag, or if you want to untag it, you can do that as well. For EnGenius, we use tag and untag. Most of the brands use that terminology as well. If I'm not mistaken, Cisco uses access port and trunk port instead of using trunk, tag and untag, but it's basically the same thing. So when you're applying VLAN, it will be very easy for you because you can easily go through the UI and select which ports you want to tag and untag. So the system setting is actually the same as the general setting right here. So that means all the switches would carry the same information in terms of my system setting unless I override. Now, once I override, then I can change the individual switches settings versus the rest in the group. So the option that I can change here, one is spanning tree protocol. Let me go over the different options here. So spanning tree protocol is used to prevent loops from happening on your system. Excuse me. Let's say, for example, you have a switch, you plug it on another switch, and then you didn't know that somebody else already did the same. You have two cables running from one switch linked to another switch. When that happens, you have a loop. If you don't have SDP enabled, what's going to happen is you're going to have a storm. So the frame would have no way of escaping the switch. It would just go round and round until it accumulates a lot of frames on the switch until it eventually overloads and hangs. So what spanning tree will do is it will identify if you have a loop on the network, and then disable some ports to prevent lat loops from occurring. Let's say, again, same example, two ports plug on the same switch. Opposite end, you have two ports as well, plug on another switch. So what your switch would do, or what spanning tree would do, is disable one of those links to prevent the loop from occurring. Next option we have here is LLDP, or Link Layer Discovery Protocol. So this is used by the switch to recognize the devices that are plugged in on the system. By default, it's enabled as well. So as SDP. Voice VLAN, you can use this if you have IP phones on the network. So it can prioritize the voice data by recognizing the MAC address of that VoIP device. It will recognize the PBX as well as the phone system. So automatically it will prioritize that for you. QoS is also used for prioritization of data for different types of data. So you can set the QoS options here accordingly. Now, all of the switch settings that we have are standard, meaning these are part of the IEEE, and whatever terminology we use is the same across the board as well. Here, IGMP snooping is used for multicast packets. It can, what do you call this? It can prevent invalid frames from being broadcasted on your network. And then you have jumbo frames. So jumbo frames is used if you want to increase the size of your frame to have more packets that can fit inside. Like I mentioned in the OSI layer, a frame would encapsulate or hold a packet. So if you increase the size of your frame, essentially you're increasing how much you can carry inside of it, making the data speed transfer faster. But one downside of jumbo frames is usually network switches would understand jumbo frames and routers, but not end user devices or PCs, for example, unless you can configure the NIC card. So jumbo frames would make your network transfer faster from switch to switch, but not switch to client device. So be careful when enabling jumbo frames as well. If you enable it and the device don't support it, basically they won't be able to receive that frame on their end. So under port settings, you have individual specific port options right here. Let me expand one of the ports. So first option I have is the speed or the duplex mode. By default, it's set to auto. Unless you want to specify a specific speed right here, I would suggest to keep it at auto. Because, for example, on one end, I have my port set to auto, and then the other switch, it's set to a fixed port. Basically, it will fall back to the slowest speed, or worst cases, it may not be able to communicate with each other at all, unless they're set to auto negotiate. Now, to ensure compatibility, please set the speed duplex mode to auto. PoE, you can individually disable or enable it per port, and you can set a priority as well. You can set the power limit. If, for example, you're utilizing all the ports of your switch as a PoE, and you have one specific port where you have an IP camera that's very important to you. You can't let this IP camera run out of power, so you can prioritize that port. So in case you lose your power budget, the rest of your devices can have lacking power, but you can prioritize one of them to always be alive. And then this is where you can configure your PVID or your port-based VLAN. Basically, it's what VLAN ID is on the specific port. So this is where you can specify that. Again, VLANs, I'll be talking more specific about this and different network applications on the next webinar. So port isolation, basically you isolate one of the ports specifically from the rest of your switch. So it's as if that this port is independent. And then rate limiting, similar to how bandwidth throttling is on the access point side, is basically you can limit the upload and the download speed on your switch, or the ingress or egress. And then some of the other options are QoS and flow control. So on the cloud, you can also configure port mirroring as well. Port mirroring is usually done if you, at most cases, want to troubleshoot or you want to know what's going on a specific port. You use this together with a monitoring software, such as Wireshark, for instance. So, for example, you want to monitor port 24. You want to see all the traffic that's coming in and out of that port. What MAC addresses are passing through, all the TCP ports, UDP ports. You want to monitor everything. So what you can do is set your destination port. Let's say my PC with Wireshark is plugged on port number 2. So that's my destination right here. And then I want to monitor port 24 for both ingress and egress, meaning inbound and outbound traffic. So we just have to select ingress and egress as well. And then from there, all the traffic would be mirrored to port number 2. So you can see all the data that's running on port 24 without any filtering. So link aggregation is used if you want to have more bandwidth in terms of the transfer between port switch to switch. So let's say, for example, I enable LACP and then I select my member ports. Let's say, for example, I want to have more bandwidth between this switch to another switch. I want to increase the capacity from 1 gigabytes per second to maybe 4 gigabytes per second. So for me to do that, I can use link aggregation, combine 4 ports to basically have 4 gigs. Repeat the same step on the connecting switch. It doesn't matter if it's a different port, that's fine, so long as you have the same number of pairs. One thing about LACP is that you have to have the same port speed as well. If you're connecting a gigabit switch, the other end should be a gigabit switch as well, with the same speed duplex settings on the port. So once I enable this, I basically am creating one logical port of 4 gigabytes per second. You can have a maximum of 8 ports for your trunk, for your LACP. So you can have, for example, on a gigabit switch, 8 gigabytes per second. And you can have a maximum of 8 different trunks enabled as well. So for the log options, it would show you what are the errors or warnings that are going on the switch. If, for example, STP kicked in and blocked specific ports, you'll be able to identify that from the logs too. And then, of course, if you're using the cloud to manage the switch, you have your topology view, wherein it can auto-generate all the switches settings. If I'm not mistaken, this uses link layer discovery protocol to identify the access points and the other switches on the network. So for example, I have my switch right here. I can see which port it goes through, if it's plugged from one switch to another. Let me borrow one of our client site because they have a very nice topology there on his end. So here is one of our client site. You can see how the switches are interconnected together. They also have redundancy enabled. So the redundancy here is this blue dotted line. So redundancy is used for, let's say one of the switches goes down, it still has a way to get back to the network through the redundant port. For example here, so let's say this switch right here goes down. I still have a way back to the network through my other redundant lines that are currently plugged in. So again, from here, I can also see how the switches are connected from switch to switch, which port to which port. If I have my access point plug-in, I can also see if the access point is plugged through PoE, how much power it's consuming, what the port speed is. So if you're using a fiber, you'd be able to determine that as well. For example, from this switch to this switch, it's plugged on port 25. So port 25 is one of our SFP slots. And you can see the speed right here is 10 gigabytes per second. while this switch to this switch is also 10 gigabytes per second. So you can see from here how the switches are interconnected. So it seems like all his switches are using fiber. So that's good. If it's plugged through Ethernet, you'd be able to see that as well. And what's your Ethernet speed? We have other options if you manage the AP on standalone mode. Let me show you guys that one just a while. Okay, so this may be a bit slow because I'm just accessing this network remotely. So this is the ECS 1008P. Whatever switch you're using for the ECS side would have the same features. So immediately, if you notice, once you log into the ECS, if you use the EWS, is that you only have one tab right now. You no longer have a controller tab to manage your APs. And then from here, you can quickly see that you have additional options such as ARP settings. So you have your ARP table on this layer 2 plus switch. So you can identify the IP address and the MAC address where it's tied to. You also have your static routing here, which you can't usually do on a layer 2 switch. You also have a neighbor discovery table. This is more on the IPv6 side. The HTTP snooping options are here. So again, this is used to prevent rogue DHCP networks or rogue routers from being plugged on your network to have clients connect to that router. And then you have your DHCP relay option right here. So for DHCP relay to work, again, what DHCP relay server is for is that, or DHCP relay agent does is it allows clients or hosts on a different subnet to connect to different to a DHCP server off another subnet. So you just have to fill in the DHCP server's information from here. Now, these options are not available on the cloud yet, but R&D is working hard to try to have more options on the cloud soon. But apart from that, the rest of the options should be available on the cloud, apart from that information. So like our EWS switches, the ECS switches are also equipped with 2 partitions, an active and backup partition. That means if for some reason the software crashes on your switch on the main partition, it's like a form of redundancy. So the backup partition would be up. It would carry the same settings of the existing partition. So it will, in a way, it will keep your services still alive. And then you have the rest of layer 2 options right here. So right now, if I'm not mistaken, the only things that are not available on the cloud UI are your ARP settings, DHCP snooping, and DHCP relay, as well as your static routing options. So this is your MAC address table, by the way, wherein the switch learns over time where the MAC address is, where can it find it on the port of the switch. So over time, this fills in to learn all those devices. So you can see a lot of MAC addresses here because this switch is hosting a couple of APs. So all the APs that are plugged on port 5, for example, I forget which port the APs plug into. It's either 5, 7, or 8. So all the devices are plugged into port 8 would be recognized by the switch over time by its MAC address. It will learn it over time, put it on the record. So when you try to transfer data from one port to another, it can easily find out without having to waste broadcast packets on the network. Okay, I just saw that we have a lot of questions now. Thank you, Michael, for helping. Good question right here. Um, when will be a good time to upgrade before the device becomes obsolete? I think you're referring to layer two or unmanaged switches. But I don't think unmanaged switches, layer two switches, or layer two plus switches would be obsolete anytime soon because they're still integral parts of the network. The reason why a hub became obsolete is because of its inefficiency in terms of network traffic. A hub keeps on broadcasting data through all the ports, wasting a lot of processing information and increasing network collisions. So that's why the hub was deemed obsolete. But switches in general are still being used everywhere. I don't see it being obsolete anytime soon. So next week's topic for the webinar would be about link aggregation. The following week would be about VLANs. So the VLAN topic may be very technical as well, because VLAN, in a way, is very complex, but it's very useful if used correctly. So, do you guys have any follow up questions? I see somebody raising his hand. Please go ahead. Unfortunately, I'm not able to hear you, but you can use the chat function to type in your question. To the 1x setting, you can quickly find that from here. Let me show you. By the way, if you're looking for a specific option on the switch, one thing good about our switch is we have this search tool to help you navigate. Let's say you're not familiar with our user interface, you want to find a specific option. Instead of going through that options one by one, you can type in the feature right here. Let's say, for example, 802.1x. Oops. So all our 802.1x setting would appear from here. Same goes with other options such as VLAN, QoS, etc. So 802.1x can be modified from here. And then you can key in your server at this portion. The slide will be uploaded on YouTube. Yeah, I'll be uploading the slide on YouTube as well as this recording, including the questions, the Q&A portion. By the way, on our YouTube page, we currently have, if I'm not mistaken, 10 topics for the cloud for the previous webinars. So if you guys missed the previous webinars, which covers the access points in general for the cloud, you can view those as well through our EnGenius APAC page. Okay, question about 802.1x. Which switches are able to do this? Currently, all of our switches, EWS and ECS switches, support 802.1x. Can you explain a bit about IGMP? Okay, let me try to explain a bit about that. I don't have slides for IGMP, unfortunately. But basically, IGMP, or Internet Group Management Protocol, this is used for multicast. Usually, you use IGMP to inform the rest of the people which multicast group you belong to. So when that happens, when a device tries to broadcast something in multicast, you would be part of that group to receive that information. Okay, there's a question here about switch warranty. That would depend on um, the what do you call this, on the salesperson that's handling your country. So if in case you want to ask about warranty on the switches, please ask the sales manager so he can give you in-depth information about the warranty. Okay. Okay. So the question was actually not for 802.1x, but for VLANs. So are EnGenius switches able to set IP address range for VLANs? Uh, um, if you're asking if the switch can act as a DHCP server, no. But if we can separate different networks using different IP addresses through VLANs, yes, we can do that on all of our switches as well. So since our switches are fully managed layer two switches, you'd be able to do VLANs fully. Let's say you're working on, for example, 10 different VLANs, having each of them have different subnets or different networks. So each of those VLANs can um, have different IP address range. You just have to set it up on the switch side in terms of your memberships and isolation or separation of your VLANs. But in terms of the DHCP server, where those IP addresses would come from, they would still need to have their own DHCP server. How many ports can you link through link aggregation? In one link aggregation group, you can have 8 ports maximum, so you can combine a total of 8 ports, and then you can have a total of 8 groups on the same switch. So 8 groups can have a maximum of 8 ports each for link aggregation. Can you disable multicast in your switch? Um, Multicast, as in you only want the switch to do unicast broadcast. Is that the question? Okay? The question was, can you disable multicast on your switch and only allow unicast? You can do that as well. In terms of static routing, but disabling broadcast entirely, it 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 depends on the function. Because for a switch to learn where the devices are on which ports, it also has to do a broadcast on the network. Okay, I think we have room for a couple of more questions. Can you explain the HTTP server on an ECW switch? Okay. Unfortunately, our switch, it's a layer 2 plus switch. It's not an L3 switch, so it doesn't have a DHCP functionality. But it can link to existing DHCP servers. Can unmanaged switch becomes manageable when a new layer 2 switch is added on? Unfortunately, not. The switch type, it can't be changed. It's locked on the hardware itself. So yeah, Michael is correct. The managed switch will still be unmanaged if you add it on layer 2 plus. Even if you add that same unmanaged switch on your layer 3 network, it would still be unmanageable. Okay, if multicast cannot be disabled, can you configure the switch to only allow some ports to open? If you're referring to physical ports, yeah, you can do that. But if you're referring to, let's say, for example, UDP or TCP ports, the switch won't be able to do the filtering on that layer. But yes, physical ports you can specify which ports you want to be open. You can also use, by the way, the access control list to specify which port a specific MAC or a specific IP address will use as well on the network. In a way, you can use the blacklist or whitelist function. For TCP and TCP and UDP ports, no, you won't be able to filter that on the switch side because we only we work on the layer 2 subnet. So TCP and UDP, they're on the higher levels of the network. If you want to filter out TCP and UDP packets, a firewall would be more sufficient in terms of doing that. Okay, so I guess that's have the time that we have today. Um, okay, one last question right here. What about our layer 3 switches? EnGenius doesn't have layer 3 switches yet. What we have are layer 2 plus switches. Okay, so yeah, sorry guys, we extended a bit over time. I'm just gonna try to edit the video out. So again, I'll be uploading the video on YouTube. Hopefully, I can finish it by tomorrow, and then we'll let you guys know once it's available. If you guys need a slide, I can share it to you as well. So you can ask the slide from the respective country manager that's managing your country. So I can pass on the PDF format. If you have further questions or additional information that you need to know, you can approach our distributors across the world, or you can approach the country manager as well to pass on that specific information. Yes, currently we only have layer 2 plus. We'll let you know once we have plans to release layer 3 as well. So thank you guys for attending today's webinar. So again, next week's webinar will be about LACP and link aggregation. But it's again going to be a bit technical in terms of the terminology, but I'm going to try to explain it in a way that you'd be able to easily understand them. So thank you guys for attending today's webinar. Have a nice day and take care.